In the fourth part of this video series on object-oriented development in the ABAP environment, let's finally address the problem with our class that it doesn't catch any errors, and talk about the concept of exceptions in object-oriented programming. All right, all along we've had our class structured in such a way that we, in the constructor, pass in the 3 keys needed to read a unique flight record. And we have our constructor where we select that record from the database, but we don't check to see if we actually found a record. So we're really creating invalid instances that don't have good data in them. We're never informing the calling application that something is wrong, that they passed in invalid data, and we go on with our processing. And that's not good. We're just keeping things simple here as we progress through our concepts. But wouldn't it be so much better to be able to properly handle that exception, that exceptional case when something's gone wrong, and respond back to the calling user in a useful manner, not just throwing a bad return code of some sort, but really sending them back a message or some data that lets them know that things went wrong. And that's what we're able to do in object-oriented programming is do more than just raise a bad error code, but we can actually raise an exception, is what we call it in object-oriented programming, and it's a special type of class that is associated with different error conditions, and we can pack data into instances of that class. It's just another object-oriented concept, but a special one for handling error situations. So let's look at our particular scenario here. What we want to start with is some messages. So I've prepared a message class, and inside this message class, really just have 2 error messages. One is some sort of general, generic error, not very helpful. General exception, sort of a catch-all. If you don't know what went wrong, you could respond with this message. Not really, as I said, very helpful. Then next we have no flight found for airline, and then a placeholder for a variable. Okay, so this is the one that we're going to use in our constructor if we don't find a matching record. And we want to raise that exception and send this nice message back, and even pass in a variable here. Ideally, we'd probably want to put all 3 of the keys in. I just wanted to keep things very simple for the purposes of teaching at this point. I'm just going to take one variable, show you how easy it is to process it though, and then of course you could build on that and pass multiple variables out in a more complex message. So we've got our text messages that we want to utilize. Now we need to create an exception class, and when we create our class, there's different types of classes that we can create by supplying a superclass. Now it's getting us a little bit into inheritance, because you're telling your class to sort of take on some properties from almost like a higher order template. And this is how all the exception classes are structured in the ABAP environment. There's different types of exceptions, and it's the inheritance of the exception that tells us the type that we want to be able to process. So here we're going to say CX instead of CL. That's the other thing. So CL or ZCL or YCL, whatever namespace you're using here. But the CL means class, and CX means exception. We want to take the SAP standard static check exception. Sorry, I keep wanting to say that. And that's what we're going to use as our starting template for our own exception class. And you see that we can, for instance, use T100. T100 is actually the table where the message classes and messages processing is stored. So, I think if we had to name these interfaces again today, we probably wouldn't name them T100. We've kind of gotten away from using those kinds of technical names, but for backwards compatibility reasons, the interface name just T100. That's what's going to allow us to tie into the particular message class processing. We want to reuse those messages we've already declared in our message class. And we want to create two possible exceptions. We declare those as constants in our exception class. And what you see here is basically building the message structure here of the message ID. That's our message class. Our message number, that was the particular number. If we put these, let's put these side by side so you can see this again. So our message number, so our very general exception, which is just the same name as the exception class itself, the catch-all when anything goes wrong. And then we have our more specific message, more specific exception, flight not found, and it's going to match up to message number 002. And here we're telling it what variable we want to map into our placeholder. And we can have up to 4 attribute placeholders. And we're saying that we want to send it the car ID variable. Okay, so we have a constructor that will be called automatically by the framework when the exception is raised. We'll see that part of this in a moment. And it will pass in the text ID of what we want to the associated exception, any previous exceptions in a chain of exceptions, because there is a way to rethrow and all kinds of complicated concepts in exception handling that allows you a lot of power. We're going to keep things pretty simple here. Traditional error handling, I want to respond and catch the error and move on. And then the particular variable, if you have any variables declared, they have to be here in the constructor so we can pass in a particular value that we want to be part of our messages. And then inside the constructor itself, it's really just populating these variables to hold them. Okay, so the exception class itself is not particularly interesting other than declaring these constants for the different types of exceptions that you might want to process in your exception class. I think things get far more interesting when we begin to look at how we utilize these within our class itself. So let's pull up a new version of the class where we've not changed a whole lot, but what we've added here is this raising. So on the constructor, we've said we wanted the possibility to raise, and you just give it the exception class. Now, from within the processing of this method, or any method that has a raising for this class, we can throw any of the exceptions. So the 2 exceptions that we defined in our exception class, but normally you'd have many more exceptions. Probably all the different possible scenarios that could go wrong in this particular application, you'd put all in that one exception class. And if we look at the logic now of our constructor, we're going to select from the database, but now we're going to check to see, did we get a record back? So if the return code from the query of the database is a non-zero, means something went wrong, we didn't get a record back, we're going to raise that exception. Okay, so just declaring the raising just means it's possible to raise the exception. We still need some logic inside of our method to actually trigger that under certain conditions. And now we can say which exception that we want to call. So each one of those constants is declared and accessible as a static off of the exception class. So we use the equal greater than sign to access static attributes or constants or methods of a class, unlike the single the minus sign greater than that we've used to access instance properties of the class. And then we can pass in this case, the carrier ID into the exception class so to have that data to put it into the message. Now all the actual message processing and passing along is all done for us within the class itself by inheriting from the higher level class and having the interfaces that we did on there, the actual lookup of the message details, the parsing of the value in there. We don't have to do any of that in any of our logic. It's going to be provided for us. All right. So very simple addition to the processing of our class, just something on the signature of the class, and then checking and raising. Now let's look at the tester here. Let's go ahead and put this alongside so we can compare them again. So now we still create a new instance of our class, but notice it's inside of a try-catch block. So everything inside of a try-catch block, if an exception is raised, it can be caught. All right? That's important to note. If I took the try-catch block out of here and the exception is raised, I get a short dump for an uncaught exception. Or it could be thrown to a higher level class. This gets us, once again, a little bit into inheritance that we'll see later. But there is a way to propagate exceptions up the chain and let another class in the call hierarchy actually respond to the exception as well. If I would declare this inside of raising on this method as well, but we don't have any inheritance, any hierarchy. That's all for the next video. So we want to catch it ourselves, so we got to put it inside of a try block, and I'm going to catch, and you've got to say what type of exceptions you want to catch. There could be different methods called here. There could be multiple exceptions raised, different conditions that we want to check for. You've got to say which ones you want to catch. And then we're going to catch them into an instance, okay? Because the exception itself is a class, and we're going to get an instance of that class. And that's what I've done here. I've put it into an instance of that class. And then the instance of that class I can call getText, and I'm going to get the error message that's associated with this out, and we're going to just output that to the screen. And I'm not going to have to do any processing of the message itself. I don't have to pass in the carrier ID. That's already being passed into the constructor of the class, and it's going to be forwarded into the exception when the exception occurs. So it's really very elegant. It doesn't require the calling program to have a lot of specific logic how to deal with that exception. If it doesn't want to, kind of defer it to the originator of the exception. It puts more power in the originator than the consumer of your code. And I think that's a good thing. It provides more consistency in the way that your exceptions are handled if you defer that to the originator. But at the same time, if I wanted to, I could completely override what's happening there and put out my own message. Or from the CX flight, I could inspect the data that was passed in, the carrier ID. I could get that from the exception class as well. So it gives us greater flexibility in how we want to handle, better visibility to what caused the exception, the supporting data. We can pack more data into an exception. It's all around a much better situation than what we would have with traditional exception handling. So let's go ahead and execute this. So let's go, run as console, and what we see here is the first one now outputs as it did before. But as soon as that exception is thrown, when we create the instance of the second instance, the one with invalid data being passed in, our processing stops at that point and moves immediately to the catch. It does not continue with the processing flow. So we don't see any write statements with the bad data coming out. We just see the error message itself. That's the other thing here. We don't have to, if we had, we have multiple instances being created, we don't need if statements after each of them. So really it's a more elegant flow where our exception processing is still happening. our catching is still happening. We don't have to junk up all of our program flow with a lot of inline exception handling at each point where it could occur. Don't have to put it after each of the constructors. We've got one general catch that can catch the exceptions from either of these. And once again, looking back at our earlier example, we did look at this one earlier. Let me pull up this 5A, where we had an internal table of processing. And the same thing can happen here. We can put our try catch outside of the loop, and if any one of these constructors inside the loop would fail for some reason, and they will because we're reading from the database, and then we stick our own value onto the end of the internal table, and it's a bad value. So we're going to have one bad value in here, but it's going to stop the processing in the loop at that point and go immediately to the catch statement. That's why earlier when I tried to show you the internal table in the earlier video, and I put the dummy code in here and set my breakpoint, it didn't stop on it because I was hitting my exception, and I was never getting to anything outside the end loop when I hit the exception, because I was immediately going to the catch processing and then not resuming where it left off. So it's not going to just continue with the next loop. If I wanted it to continue with the next loop, I'd have to put a try catch inside of the loop. So where you position your try catches and your processing hierarchy here, if you will, really has a lot of impact. So we can go ahead and run this if you want, just to show you the output here. Oh, I still have my breakpoint set. Let's not switch, because we're just going to go ahead and continue processing. We did hit our exception. We know we hit our exception because we hit our breakpoint, which is only inside the exception handler. Output all the data very nicely. Of course, it's going to find it because we're reading it from the database, but there's one bad record that we stuck in here at the end. And of course, at the very end, we see our error message coming back out of the exception handler there. So I hope you've seen that exception handling is a much more elegant approach in the object-oriented concept than the old just checking return codes and being able and having to handle all the processing logic within the calling application. We're able to centralize things better within the class, the originating class of the exception, pack more data along with what occurred in the exceptions, including message processing. So we have, and the whole concept of try catch also makes our code cleaner, more elegant, because we're not junking it up with a lot of repeated exception catching inside the flow of our code. It's all about more maintainable, more readable code these days. Creates less errors and, really reduces the cost of ownership of our code over time as well.